Let me introduce you to my new lab bench power supply that I just built. It contains two individual channels, each featuring a 150 watt OS/kg boost converter connected to an XL4016 buck converter. Now, while wondering what video to upload next, I came across a video that I uploaded before at this subject. While watching the video though, I noticed that I have made a really big mistake in the video. So, without taking out any more time, let's get into the video. Before finding the mistake though, let me explain how the calculation of power works. When you attach a load to a power supply, it draws current. In my power supply though, I can set the current limit, which means when I set current value is reached, the voltage will break down like shown in this clip. This value can be increased or decreased depending upon our requirement. In the efficiency test video, I have shown that my power supply outputted 192.2 watts at 24 volts. But sadly, it was just 8.3 amps at 3.3 volts, which makes up to 27.39 watts. A big difference. The reason was simply that the voltage dropped to 3.3 volts when drawing the showcased 8.3 amps because the resistance was too low. Therefore, it needed way more current, more than 60 amps to be exact. So let's see the real test now. For that, I used a solid nichrome wire featuring a resistance of 2.23 ohms compared to the previous 0.39 ohms load. Okay, now let's start the test. I simply cranked up the voltage and current settings till I reached a current of 5 amps at the output, at which point the voltage was 14.2. The input current was 6.35 amps at 14.7 volts. Of course, the idle current of 350 milliamps is not included in these tests. So here we get 71 watts on the output and 88.2 watts on the input. Therefore, the efficiency was 80.4%, which is okay for a buck converter like this. Moving on to a 6 amp load. This time I got 16.9 volts at 6 amps. On the input, I got 8.75 amps at 14.7 volts. Therefore, the efficiency is 82.1%. Now, at a final 6.5 amp 18.2 volt test, the input current was exactly 10 amps at 14.6 volts. That equals an efficiency of a mere 83.3%. So in conclusion, the efficiency graph seems to slowly increase as more power is being drawn. Of course, there might be some errors in the readings, like my clamp meter's accuracy or the voltage drop on the cables. But I would say this is enough. And with my power supply tested, I hope you have enjoyed this video. Stay tech and I will see you in my next video.